So hi, my name is Ashley Williams. I'm also on the Rust support team, along with Steve. But Roberto asked me to come talk to you all today about WebAssembly. So this is the very first Barcelona Rust meetup, correct? So I was really curious just to get a sense, because I've taught Rust and WebAssembly to a fair number of people, but it's usually focused at people who are web developers. So how many people here would count themselves as a web developer? Okay, that's good. I was a little worried that I was going to try and convince you that Rust and JavaScript working together was good, and it was like a room full of Scala people. No offense to Scala people, but it's like a harder argument if I'm not working with websites. So I have a really fancy slide system here, which is mostly tabs. I'm a bad Mozilla contractor because I'm in Chrome. Alas, this is going to be how it's going to be. So before I get started, how many people here have heard of WebAssembly before? Has anybody written any WebAssembly from scratch? Artisanal? That's cool, because it turns out that WebAssembly is an assembly language, and while you absolutely can write it from scratch, you probably don't want to. So as an overview of what I'm going to talk to you about today, I'm going to do kind of a brief intro into what WebAssembly is, but my primary goal in talking to you today is how you can write Rust that you can then run in your browser. And have that Rust work happily alongside JavaScript that works like any other NPM package that you might use before. So that's the goal, and this entire set of stuff that I have is actually a tutorial. I almost asked, like, do people want to pull out computers and like code along? But if you are really interested in using this stuff, this is something that you can like code along and do yourself. So let's get started. So WebAssembly is this awesome new way basically to have a language that can have low-level access that's inside your browser. So we have JavaScript, but trying to do things like managing memory and stuff like that is like not really a thing that you are going to be doing in JavaScript. It's really unpleasant if you try. And so WebAssembly is something that's going to allow you to do that. And this opens up the web to a lot more possibilities. We've been building a lot of really awesome things with JavaScript on the web, but when we start using something like WebAssembly, we're going to be able to do a lot more. There's a lot of really awesome, like people have been doing games in WebAssembly. People have been doing machine learning in the browser using WebAssembly. Any type of thing that's going to require like a high amount of processing is a really good target for WebAssembly. Moving on to this. So this is the curriculum I have. If you want to check it out, you can go to this URL and tweet it out too. And some slides. But first, let's take a little bit of a look at what WebAssembly actually looks like. So if you're a web developer, you probably are a huge fan of the web inspector. It's really cool to visit a website, especially a website that's maybe trying to do evil things to you and be able to open everything up and like turn off the JavaScript, or like, maybe you want to take a screenshot of the New York Times where you've edited the title to say something different, because fake news is awesome. Just kidding, it's bad. But a lot of people have heard that WebAssembly is going to break the web and that you can no longer look into what is actually happening there. Has anybody heard this? No, okay, a couple people. All right, so I'm kind of here to say that while WebAssembly does create a binary, there are human-readable versions of WebAssembly. So this is a tool made by Mozilla called Webassembly Studio. It's not really like a full-fledged IDE. Like, you're not going to start writing Rust that generates WebAssembly in this for like your production code. But if you're interested in exploring WebAssembly and being able to take a look at all of the things, this is a great little tool to check it out. You can just go to webassembly.studio to do so. And so there's a lot of different languages that can target WebAssembly, but Rust is a particularly well-suited one because of its lack of a garbage collector and lack of runtime. So other languages that you can target WebAssembly with include C and C++. A lot of people have asked, can you compile JavaScript to WebAssembly? And so in my head, that kind of makes me smile, because I'm like, why would you want to do that? That seems a little silly. But there actually is. There's something called AssemblyScript, which is actually pretty cool. What are the reasons why you wouldn't want to take like a dynamic language, like maybe like Python, or even something like Go is not a dynamic language, but Go also has this issue. Is that if you want to have a language that requires a runtime compiled down to JavaScript, compiled down to WebAssembly, you're going to also have to include that runtime. And so all of the benefits of WebAssembly, like small sizes of your bundle and make it going really fast, kind of go away if you're taking a language that doesn't have this kind of like lack of garbage collector, lack of runtime thing, and then kind of shoving it into WebAssembly. And so that's why Rust is particularly well suited for this. So how many people here have ever written C or C++? Keep your hand up if you'd like it. Yeah, hands always go down. I know people kind of put it up. I'm not here to hate on languages. I think all languages are really cool. But as somebody who teaches beginners a lot, and also as someone who is like a self-declared like lazy programmer, I really like Rust because all of the mistakes that C and C++ say, yeah, you can make those if you're like not smart enough or not paying attention. Rust goes, hey, definitely don't do that. I'm not compiling until you fix that. And so I appreciate that the Rust compiler is trying to keep me on the right track. And so for folks that are interested in something like WebAssembly, I think Rust is a great choice because you at least get a buddy when you start trying to learn the language, and the buddy is the compiler because it's trying to help you out. All right, so the cool thing about WebAssembly Studio is that it's just going to build a tool, build a project for us, assuming that the Wi-Fi gods are on my side. They are. All right, so we have an empty Rust project here. As you can see, WebAssembly Studio is already really not giving you everything that you want. There's no cargo tunnel here, so you're like, wait, how is this working? But we do have some code, so let's take a look at what our main looks like. All right. Why is it running this code? Oh, did I make it run a C? No, it wasn't.
It was the hello world, and there was the non-hello world.
Oh, I want the hello world one.
Yeah,
this is kind of a gross one. All right, let's pick hello world instead. Yes, this is much better. This has like just a lot more features in it, and a lot of the annotations that you saw in there are completely unnecessary. So here we go. This is what we're looking for. All right, great. So this is a Rust library that will, if you run it in your browser, will pop up an alert window. So let's take a little bit of a look at what's going on here. I'll dive into some of these tools first, but what this is able to do is you're able to kind of mock out the fact that you want to call a browser function, the browser function alert, because there's no alert or window in Rust. And then what we can do here is we can write this function greet that takes in a string, and then we'll pass that string into the alert function here. So this is an extremely naive example. If you want to use WebAssembly, you almost certainly are not going to want to pop up an alert window. But this is a great way to kind of start playing and getting excited. So we can see that work by just running build and run. There we go. It's usually shorter than that. I think my Wi-Fi connection is not very good. All right, but if you want to play around with WebAssembly Studio, you should definitely take a look at that here. All right, so let's hop into my slides. All right, so I'm taking kind of bits and pieces of this presentation because you already got the not so brief intro to Rust. And since a bunch of you have already used it, that's great. But what I want to walk you through today, again, is writing a crate. How many people here have published a crate? Rust. All right, how many people here have published an NPM package? All right, so the goal, usually when I do this as an interactive workshop, I'm like, all of you today are going to publish an NPM package that has WASM that was generated by Rust. But you can do that maybe right after the break. We'll see. So I work on one of the domain working groups, as I was talking about before. That's part of the Rust 2018 edition. I'm on the Rust and WebAssembly working group. And one of the biggest things that we're focusing on is WebAssembly is a super cool technology, but there's all sorts of really awesome technologies that have existed. And the only ones that actually succeed are the ones that people use. And so we've been working really hard to build out a bunch of developer tools to make it so that not only is there this like really awesome technology, but using it is great. And I've been telling this group for a while that the primary audience that we're targeting this WebAssembly work with is JavaScript developers. And JavaScript developers love tooling. They love tooling. They also love to hate the tools that they love, but they love them, but they also hate them, but they do love them. They have to have them. They must exist. And so we've spent a lot of time building out some tools. And so a lot of today is going to be introducing the tools, because when we tell the Rust WebAssembly story, it's really a story of the tools that we're going to be using to make this happen. So the first thing to say is, all right, how does a piece of Rust code, all right, end up as code that can be consumed by the browser? And so there's been a ton of really awesome blog posts illustrated by Lynn Clark, who is a dev evangelist at Mozilla. She does a bunch of things called code cartoons. And we're going to talk about these steps right here. All right. So the very first thing that you want to do is you want to write a library in Rust. Now, there are some folks who are trying to write completely 100% full applications in Rust, like write an entire Rust application, put it in WebAssembly, and then like throw it in the browser. And that's like a super cool idea, but I'm not sure that that's the superpower that the Rust WASM story has. Instead, I think the superpower that the Rust WASM story has is supercharging just a part of your application. And so when we say write something in Rust, we're not saying write a whole library or write a whole application. We're saying write a library that focuses on a particularly like hot path of your JavaScript. I mean, for the people here who said they were web developers, how many people here have a part of their web application that they wish they could make go faster? Really? Only a few of you? Gosh. All right. Well, hey, good for you. That's awesome. But I know I used to work at NPM, and there's about 5,000 different pieces of that massive microservices conglomeration that could definitely get sped up. So yeah, the first thing you'll do is you'll write a Rust library. And then you will use the Rust compiler to compile WASM compile the Rust to the WASM target. So recently we were at JSConf.eu talking about Rust and WebAssembly, and there's kind of this story that Steve actually tells where he's like, I know that Rust and WASM is really going to make it because somebody came up to me and asked if Rust compiled to anything besides WebAssembly. There were several people there that had figured like that maybe Rust was only for targeting WebAssembly, and I was like, whoa, that's pretty awesome. But yeah, Rust can target a ton of things, and WebAssembly is just another one of them. The target for WebAssembly in Rust is called WASM32-unknown-unknown. So if you see that and you think that looks weird and maybe isn't right, one, true, that's a super weird sounding thing, but yes, that is what the WebAssembly target is. There's another WebAssembly target that's kind of using this other tool chain that we're looking to replace, which is mscripten. Does anyone here have heard of an mscripten before? Okay, so mscripten is super cool, and there's a lot of things coming out of that project that are awesome, but I don't know, it's very difficult to get a whole bunch of that tool chain set up, and we're looking to try and make that barrier to entry a lot easier. Yeah, so you write your library, you compile it to the WASM target. Now, you can quickly learn that we love compilers because there's more than one compilation step here, which is pretty awesome. So we compile it to the WASM target, and then we have this tool called WASM bindgen, which I'll dive into a little bit deeper. But what that's mostly going to do is it's going to translate your Rust function signatures into something that JavaScript objects can understand. So you're compiling down your WASM. WASM really only has numbers. And so how many people here love using only numbers to describe strings? Yeah. It's possible. Computers, right? But it's not really fun. And so there needs to be a step between like having WebAssembly and wanting to talk to it with your JavaScript where you want to kind of construct some types so you're not doing that all the time. And that's what WASM bindgen does. Then finally, there's a tool called WASMPack, which is a tool that I created that I've been working on a lot, which kind of does all of these steps for you and also packages up all your metadata and generates documentation for you so that you can just publish it to NPM. So then, once you have that published to NPM, you can drop it into your project if you have maybe a package JSON or something you're using other NPM dependencies. You can drop your WASM in, and nobody else in your team even needs to know there's WebAssembly in there. They can just use it like it's normal JavaScript. Just like secretly sneak it in there. And we've been in the working group working very closely with a bunch of the bundlers. So when I was originally writing this, the bundler that's kind of done the WebAssembly support the fastest is Webpack. But we're also working with Parcel, which has pretty good support at this point, and Rollup. So there's a whole bunch. I also found out that I guess today somebody wrote a JavaScript bundler in Rust and released it today. So who knows? I mean, I hope their WebAssembly support is good, but I have no idea. Okay.
I think it's non-existent.
Oh, we just get fair. It happens.
Yeah.
Yeah. So this is the general pathway. So I'm assuming because a lot of people raise their hands that they're web developers here. Maybe this is not what you're looking for, but I can say that there is a lot of like fear, uncertainty, and doubt from a lot of folks in the JavaScript community that WebAssembly is here to crush JavaScript. And there's certainly a lot of people on Hacker News and Reddit who are extremely excited to like welcome the death of JavaScript as WASM like smashes it down. And for everybody who actually works on these technologies, those opinions are incredibly frustrating because it's not how we feel at all. WebAssembly is certainly not trying to replace JS because that's a ridiculous thing to try and do. Like, that's not a winning battle. But it's also not a useful one. WebAssembly is really trying to be this kind of like superpower for JavaScript. And this is why the working group in our first year of operations, primary goal is to make Rust interoperate with JavaScript as seamlessly as possible. And so if you hear anybody say, oh, yay, WebAssembly is happening, it's going to kill JavaScript, please help us in our attempt to communicate that is absolutely not at all what it's trying to do. We actually love JavaScript and want to make working with it like very, very easy. Cool. All right, so this is the part where I do all the stuff that Steve did, but we're not going to do that. We're going to skip ahead to slide 20, where we are going to write some code together. But you like the slide edit there? Or are you looking at some weird thing?
I love the jump from slide 8 to slide 20 by editing the URL. Awesome. Awesome.
Yeah, I tried. Yeah, so let's write this Rust WASM crate together. And as we do it, we'll dive into the code. And if you see something in the code, like any good live demo person, I have pre-baked a ton of this. What I will say is everything that you are looking at right now is I was like, what happened over there? Is on Nightly. If you saw me furiously typing over there and maybe making a scowl, it's because sometimes Nightly breaks. And so it broke a bunch of my demo, but I updated it all, so it should be good now. But if you are playing with this or using any of these tools, and one day everything that used to work stops working, it's probably because of Nightly. You can check out the GitHub repos. All right. So again, all of these exercises exist in the repo, so if you want to play with them later, you can. Let's hop right in. I also compulsively type clear in my terminal, so I'm sorry. I'll try to do that less. All right, so the very first step that we do is we create our crate. All right, so I have already created a bit of a crate, but let's take a look at what's going on here. So I'm going to open up our cargo tunnel. All right, so the vast majority of this stuff right here, that's all going to be given to you by using a cargo init or cargo new. But the critical things to check out here are this lib crate type, C dilib, stands for C dynamic library. The really critical thing to know here is if you don't put this, it doesn't work. And we can dive probably deeper and don't want to bore everyone with those details because they're not incredibly important. But the primary thing here to see is that we require one dependency for this project, and it's going to be this tool called WASM bindgen. And it might be like, Ashley, you already talked about WASM bindgen, and it's some sort of translator tool. One of the things that I think is perhaps a little bit less inviting is that WASM bindgen actually has two pieces. one of the pieces is a library, and you're going to see how we use it in a second, and the other piece is actually a CLI tool. You can download it on your own, but WASM will take care of that part for you. So you don't have to worry too much about that. But you will still need to use WASM as a library. And so here's how you would set up a general project. Any questions on cargo.com? Yes.
If you want to create an application, you have to change the create type.
If you want to create an application?
Sí, yeah, instead of library. Or it's more different.
Probably this. I'm focusing like exclusively on building libraries here. So WASM also is probably going to be a little spicy at you if you're trying to build an application, because all of this is designed. Like when I said that WASM is not trying to replace JavaScript, the tooling that we have focused on building so far is so fundamentally focused on the idea of creating a library that works with other JS libraries that like we're really focused just on the library story at the moment.
Other people have written tools that do like you do that.
Oh, yeah.
There's a React-like framework called Vue that lets you write an application. It's just different.
I just can't imagine a single company right now that could replace its entire web team with enough Rust developers to write its entire application with Vue. I'm working on this because I want it to win. So I'm trying to get the easiest sell. Yeah. Other questions? All right. So that's our cargo.toml. All right. So let's hop into, well, first I'm going to remove all my prefig. That's fine. All right. So that's what we get. All right. So let's go into our source and we will open up our lib.rs. Also, if you're wondering, Ashley, do you actually develop with no syntax highlighting? And again, that clearly has no plugins. The answer is yes, and it's a long story, and we can talk about it later. All right, so this is that Hello World application that we saw earlier, but like, let's actually dive into this code. So one thing that a lot of people end up asking me, particularly people who are new to Rust, is what the heck are these things with the hash and the square brackets? And so these are called attributes. And what we're doing here is on line 3, I'll talk about line 1 in just a second, but on line 3, we're pulling in that WASM bindgen library, and then we're going to be using it. And WASM bindgen is heavily focused on procedural macros. And this is because what WASM bindgen does is it takes a look at your function signature and is then able to generate, WASM bindgen basically just writes a bunch of JavaScript for you. And it writes these JavaScript wrapper functions that allow you to interact with your low-level WASM using all of the JavaScript types that you know and love, or the JavaScript types that you don't love. Types. It's just object, just kidding. But it allows you to use things like strings and classes that you would want to use in like a contemporary JavaScript application that WebAssembly simply does not know how to talk about. And to a certain extent, neither does Rust. So an example of something that WASM bindgen can do is if you have a struct in Rust that you then compile to WebAssembly, if you're using WASM bindgen, if you go to JavaScript, you can now talk to that struct as if it is a class. And similar things. And we can dive in much deeper. There's an awesome WASM bindgen book that talks about all of these different conversions it does. And if you're looking to get involved, one of the hilarious things I think is that a lot of people developing WASM bindgen are not JavaScript developers at all. There's incredibly low-level fruit to be picked off in open source contributions for improving the JavaScript that WASM bindgen is generating. I know I jumped in there for like a day and added like a couple object freezes that would be really useful to make it speed up. And yeah, so if you're looking to get involved, that's a really awesome thing to do. Yeah, okay, so we pull in our WASM bindgen dependency. We say use to pull in all the stuff into namespace. But the primary functionality that we're getting from this is this WASM bindgen attribute, which is going to cause that code gen to happen. So this attribute is focused pretty much exclusively on the function signatures that you're writing here. So as you're writing your WebAssembly thing, you're going to be writing out function signatures, and any of the ones that you actually want to expose as your interface to JavaScript, you'll annotate with the WASM bindgen attribute. So again, what we have here, if you want to try and tell your Rust Because Rust is going to get grumpy, right? If I just wrote this greet function, in my head I know in the browser there's an alert function, but if I try and compile this Rust is going to be pissed, because Rust is like, what is this alert? This is not like an actual thing. And so if you want to talk about something that exists in the browser that you know is going to exist in the browser, you can wrap it in this extern block, and then just write out the function signature you would expect. So if you're not familiar with Rust, strings are a little bit more complicated. This is basically a string type that's like the simplest kind. I call it an and stir, but the official name is string slice. And stir is just how you write it, so that's how my brain works. Like here we're just writing that out because alert would take a string as its parameter argument. And so yeah, this is how you would talk about something that would exist in the browser. And this is how we write like our amazing Rust function that will go incredibly fast and compile to WebAssembly. And this is our general program. I have a couple of notes on this, but does anyone have any questions on this code? Go for it.
Why we can't write something like use WASM double column alerts?
Because no one wrote that crate yet. So you're suggesting the existence of a crate that exports these extern blocks?
Yeah. Well, some function doesn't exist in Rust, but exists in JavaScript. You could write some kind of library with alerts, with other things.
So I think what you're kind of suggesting is, gosh, it would be really great instead of having to like trust myself that I know that alert is there, to have some sort of canonical set of all of the API that's exposed by the browser. People are working on that, and if you want it, come join us. A lot of the work right now that we're doing in WebAssembly is this kind of like interop, like is it supported work? Like originally in WASM BindGen, we were like, okay, what is the JavaScript version of a Rust struct? Okay, what is the JavaScript version of this number? What is the JavaScript version? And it's really just a really, really, really big long list, and you just are slowly checking them off. We're doing this for WebIDL support too, and there's a WebSys crate that's also doing that. So yes, it would be way better. It's not completely there yet. Another thing along these lines that people often ask for is DOM support in WebAssembly, and I know a little bit less about how that's working out right now, but it's coming. But again, it's a lot of just getting it there. It's a little bit complicated.
Is JSON support is already here? Can WebAssembly work with JSON structures?
So JSON is a string, and JSON, so you can translate the string into numbers.
JSON is an option. I mean, right.
So WebAssembly only understands numbers, but there are ways to translate what that JSON is into something that WebAssembly understands. WebAssembly doesn't have like pure JSON. Like you can't like throw JSON at WebAssembly and have it like get it.
How you can interoperate with JavaScript code without JSON?
How can you interoperate with JavaScript code without JSON?
Yeah, but well, how you can call some...
I write lots of JavaScript that doesn't use JSON.
Okay.
I'm not entirely sure what you mean.
You can just call JavaScript functions directly. You don't need to interact with it like an API. You can just literally call the JavaScript function directly, and it will just work.
Well, calling them without arguments is one thing. Calling them with arguments is much more powerful.
Yeah. Well, in this example, you're calling it with a string as argument.
Yeah.
Yeah. So the alert gets called with a string, and WASM BindGen converts it.
Okay.
Well, I just know one example. There is a language like Dart. You know Dart language.
Yes.
It's trying to interoperate with JavaScript and not to replace JavaScript, but Dart cannot work with JSON. And it was when I realized it, it was like stop for me, because calling things like arguments only strings, it's kind of utopia, because it's not really realistic approach.
So we support multiple different types that are not just strings. We support JavaScript objects, but not JSON in particular, which is not quite a JavaScript object. They're slightly different. But just to let you know, I'm jumping a little bit ahead here. We'll go back into the demo for a second. But I think it's a reasonable time to go, okay, what does WASM BindGen support right now? Right? That's kind of the question you're asking, just a little bit. And so there's a whole bunch of things that we actually support. And so if you're curious, this is the WASM BindGen guide. And this not only is going to tell you how WASM BindGen works, it's going to give you a pretty good sense of what we are able to support right now. And classically, as an open source project, it's going to strongly encourage you to contribute. What you can see here, we're talking about JS objects in Rust, because it's not 100% true, but basically everything in JavaScript is an object. If I tweeted that, like 5 people would be like, no, it's not. Basically, it's a completely reasonable thing if you have an understanding that everything in JavaScript is an object. And so that is something that we absolutely do support. You can definitely work with objects. And so there's a lot here about talking about how to export a function in JavaScript, a struct, you can customize your exports, classes, these are all the rights to type conversions, types in WASM BindGen, maybe we can hop into that. Oh, I don't really think. One of the things about this is that WASM BindGen is an awesome, awesome tool, and it talks about all of the things that we support, but fundamentally, we don't want you to have to think about this. Like, if we have succeeded in our goal of making Rust like a first-class language for targeting WebAssembly, you should not have to worry about what WASM BindGen is doing. It should just do exactly what you want it to do. And while we're definitely working on developing it, like being able to interact with something like JSON, like you can't just like take JSON and put it into WebAssembly because of the restrictions of WebAssembly. WebAssembly spec is incredibly small and it really only has number types. But you should be able to do everything that you would want to do using Rust and being able to compile it to WebAssembly. So, if you want to dive super deep into what WASM BindGen does, you can definitely check all of this out. As an aside, WASM BindGen kind of has made a decision to be kind of ES6 modules first. So whenever you use WASM BindGen, it will by default create an ES6 module wrapper for your WASM for you. But are there any Node developers here who are still using CommonJS? That's like it's a real thing. People are definitely still using CommonJS. WASM BindGen is able to export that as well. So. Cool. So let's hop back to this code because I'd really like to get you something that is actually working and prove that this is something you can actually start using today. So the last thing here that I haven't talked about is this line right here. And this line is the line that changed today. But before this used to say procedural macros, but because procedural macros are actually part of the 2018 edition, small parts of them are kind of starting to land in nightly, and the goal for the WebAssembly working group is that we have everything to, like, in the Rust language stabilized that will make it so that we can move our entire tool chain to stable. Right now we depend heavily, especially on procedural macros, because again, this is just doing a ton of code generation that's based on your code here. And so hopefully that will be gone, and then ideally, this should all be a line that you never have to write. So this is why I explain it last, because people are like, that's the most confusing looking part. And I'm like, true, and we're going to make it go away, because it's not great. This is just telling us that we want to opt into certain features that currently exist on Nightly. But once they're stabilized, that's not something that's necessary. All right, so just to do this kind of alert hello world, this is the code that you would write out. And after this point, it's really just leaving it to the tools. So does anyone have any more questions on this? All right. If you're curious about a less naive example, there is a really great one that I'll show you at the end. Okay. Okay, so once you have written your library, what we're going to do now is we are going to package this up so that we can publish it on NPM. And the way you do that is you're going to use this tool that I wrote called WASM Pack. If you want to read a little bit about the goals and what WASM Pack does today, you can check this out. This is published on the Mozilla Hacks blog. But what I want to tell you a little bit more about is a blog post that I've owed the working group for a week now, so you get the first preview of it, which is, why are we designing this tooling the way we are? So developers are really attached to their developer environments, and so JavaScript people really love their JavaScript environment, their Node environment, and Rust folks really like their Rust one too. And so what we realized in trying to come up with this WebAssembly story was that trying to convince a whole bunch of Rust people that they should use a Node environment, or trying to convince a whole bunch of JavaScript people that they need to download Rust to use WebAssembly was probably a big no-no. Like, the chances of our success were going to be a lot lower if we're going to require people to have all of these different dev environments. I know I have them all in my machine, but a lot of people just don't want to deal with that. So in creating this, what we decided was we wanted to leverage the two extremely strong package ecosystems that both Rust and the Node ecosystem have to be able to kind of create this barrier where, say I'm a Rust person, I want to create WebAssembly packages, but I just want to use Rust. I want to make packages for people, and like the JavaScript people can use them, but like I'm just interested in writing them. And then the JavaScript people, they just want to get their JavaScript done, and they don't want to be compiling Rust and waiting for that. Though I will say the patience that JavaScript developers have developed for compilers is like getting really good. We basically have 8 compilation steps in JavaScript now too, so it's almost fine. But I know people are tired, so waiting for another compilation step is probably not something you want. So it was really important to us that we have this kind of divide. And so as a Rust author here, does everybody know who this little character is, by the way? So our non-binary, non-official mascot, which is a crab, because Rust folks are called Rustaceans, and a crab is a crustacean, and their name is Ferris, because Rust, iron over pertaining to iron is ferrous. It's really bad. But like, if you love puns, come join us. This is what our marketing is at right now. Yeah, so this is the goal. And so one of the things, if you've been following the WebAssembly story and the bundlers, that's like a little bit interesting, that is literally just open source politics still working itself out, is some of the bundlers, Webpack actually originally released with this and then pulled it off, but this is actually how Parcel is working right now, is some of the bundlers wanted to own the Rust compilation story. So instead of saying like import my WebAssembly file, they actually have you import a Rust file and then do all the compilation step for you. And yeah, I thought, wouldn't it be nicer if all JavaScript people had to consume was something that was already prepared for them? Maybe. But I'd definitely be curious if people have opinions on this. We kind of have been asking people around and like seeing what we think. But I think consuming something that's already been compiled and is kind of prepared for you already is something that we think is a good idea. But yeah, so this is what WASM Pack does, and the primary goal here is you just kind of like hit a button, and it's just going to package it up for you. So we can hit the button right here. Now, how many people here read XKCD, the comic? A little bit? All right, so we're about to do some compiling. Did anyone bring lightsabers? Yeah? All right, so WASM Pack is a command line tool. It's distributed using Cargo, so if I didn't have it installed, I could say Cargo install WASM Pack, and it would install it for me. However, I already have it. So we can just take a look here. If you don't like emoji, you might get a little irritated by this tool because there's emoji everywhere in it. I just think it's nice. So these are all the commands right now that we have. You can create a new project, and this is for logging into the NPM registry. Pack is going to create a tarball for you, really similar to NPM Pack, and NPM publish similar to WASM Pack Publish. So this is a publisher, but it's also a builder. And we'll talk a little bit about the future of that build in just a second. But if I wanted to package this up, I can just get out of this. I can run WASM pack init. And it's going to go ahead and do a whole bunch of compilation. So we'll come back to this in a second, unless we really just want to watch the spinner. No, let's not do that. That's not fun. Let's talk a little bit about the challenges that we're facing right now with Rust-generated WebAssembly and some of the future stuff that's coming to WASM pack that's really awesome while this compiles. All right. Here we are. Okay, so the Rust WASM working group has been building a whole bunch of tools. This is our lovely logo, but this is our org on GitHub, so if you're interested in kind of following what's going on, you can kind of subscribe to this. But one of the big things is, so WebAssembly wants to be small, and WebAssembly wants to be fast. But inevitably, when you are writing something in Rust, while it's optimized for a lot of speed, wanting to make something small in the web versus wanting to make something small just like in general is like a very different thing. Like something that's considered small in general is actually sometimes kind of huge on the web because we're so very focused on the sizes of the things that we're downloading. And so we have several tools right now that help take a look at the size of your WebAssembly and make you be able to fix those. So one of the first ones is Twiggy. And so Twiggy is your first step when you walk into WebAssembly and you go, why is the binary that I just made so friggin' big? Why is this big? And so Twiggy is going to answer the question, why is this big? There's this logo. I don't know how this happened. I don't know what's going on. But this is a thing. You can tell that we're really into like characters and stuff. Where is the example of the output? Here we go. So, yeah, here we go. So Twiggy is, you can run this as a command line tool and it's going to be able to go in here and kind of show you what percentage of your binary, your WASM, that things are taking up. Like what is taking up so much stuff. And then from there, so Twiggy's great because Twiggy can tell you what's wrong, but then the next question is like, oh no, I know what's wrong, like how do I fix it? And so the first thing I'll say is like, right now we don't have all the answers. One of the reasons that we did the profiler first is because we didn't fully know the set of all the issues that we'd have to start fixing. So we've released this out into the world and we'll do best when we have as many people using this and saying, okay, here's what's going on, and then we can try and figure out what's going on. There are several other things, though, that you can kind of take care of. Where's WeAlloc here? There we go. So, how much do I want to dive into this? Because I have no time left. My computer is about to take off, so we know that it's compiling. Just to take a little bit here, so we've moved on past our compiling to WASM, but let's talk through exactly what these steps were. They're basically the steps that I've already talked about. So we added the WASM target, I already had it, so basically just skip that step. We compiled to WASM, then we created a package directory. Then we basically just serialized, deserialized and serialized your cargo toml and into a package JSON. These warnings are here because Cargo has a higher quality requirement for the metadata of your crate than NPM does. So there's often a bunch of things that Cargo would want that you don't have to give to your package.json. And we figured with this tool we'd warn on them just to try and encourage folks to improve the quality of their packages. So we wrote a package JSON for you. We copied over your README. A new thing that's happening in the future is how many people here who write Rust use Rust doc? All right. So for those who might not know, you can kind of generate documentation automatically using Rust doc. But a lot of people, when using JavaScript or an NPM package, they will not necessarily read the documentation, but they will read the README. Right? You'll read the README, but maybe not the docs. So we are currently working on a feature that goes through and pulls all of the doc comments out of your code and will generate API docs in your README for you. So hopefully people will read them. So we covered over the README, then we installed the WASM bindgen CLI, and then we ran the WASM bindgen. Just to finish up on what WASM pack is going to add, so we have all of these cool tools that are going to allow you to make your bundle smaller and potentially make your WASM run faster, and configuring them can be a huge pain in the butt. So what will be coming in the next version of WASM pack is 3 default build configurations that you can say, I want to build my WASM and I want to do it like this, and you'll get a bunch of the optimizations that the Rust compiler can't do immediately for you, with a lot of kind of the conventional wisdom behind that so that you can help make your tool smaller and faster. So what this has done now is we ran WASM pack, and now inside our package directory, we should have a package right here. Now, there's a couple cool things here that I haven't mentioned to you. Does anyone see anything that's like potentially cool that I haven't mentioned yet? Yeah, so because Rust is typed, we can just make type files for you, and it basically costs us nothing at all. And the nice thing about a type file is that maybe you don't write TypeScript, but a lot of tools that you might use will still benefit from having the types file there. So with completion, I think VS Code uses them, but a lot of tools and IDEs use these type files. So you just get that out of the box. If you hate it, you can turn it off. I mean, you don't want to add things to someone's package that they can't turn off, because they'll get really mad. But yeah, so in here what you can see is we have the types, we have our WASM file here, we have our JavaScript entry file, a package.json, and a README. So this is actually just ready to publish. So I can say WASM pack publish. I should just publish, we'll say, so slow. Oh, oops. I've done this before. Of course I can't do it. All right, so what should we call? Let's say hello WASM BcnRust. If you're wondering if I just spam the NPM registry with my workshop packages, the answer is yes, I do. It's fine.
They like it.
They do like it. It makes their numbers
Makes
go
their
up.
numbers get bigger, so.
I'm wondering if Webpack can be integrated with Cargo.
If Webpack can be integrated with Cargo?
Yeah, you can do Cargo build, Cargo publish.
Yes, and it basically already exists. With the Webpack team, we've been working, the Rust WASM working group's been working with the Webpack team, and they have what is now called a Rust plugin for Webpack. So if you wanted to run like WASM pack from Webpack, you could, and it would do all that stuff for you. I don't know why.
I think you're saying the other way around, from Cargo to build this stuff, not from Webpack to build this stuff.
Oh, is that true?
Yeah. From Cargo.
Oh, to do Webpack from Cargo?
Yeah.
Probably. Also, our package is published. Yay! I'm about to show you how we can drop this into Webpack. There's probably ways we can eliminate even more steps. But
Cargo
yeah.
isn't like customized Cargo build, so you can't do it. So sure. But in the future.
I
know.
I just need to finish because
Yeah,
I'm going
sure.
so long.
It's cool.
Cool. All right, so we have published our package. That's super cool. We can check it out on the NPM website. Do you want to see all the really terrible packages I've ever published? Also, it needs to be this. Oh no, this is, I also published a package with my name. So, and it was deprecated because I don't work there anymore. Yeah, look at, what is the ordering on this? Anyways, I have 83 packages, and so, anyways, we can trust that this hello WASM package is here. Yeah, I'm just gonna have to scroll forever, and that's gonna be a huge pain. Yeah, anyway, so this package exists. I spelled that right? Yeah. Okay, yeah, so this crate exists or this package exists right now, and we can now just drop it into a Webpack project as if it was JavaScript, and it will just work. So let's do that. So I'm going to come out of the crate, and I'm going to hop into the website. So how many people here use Webpack? Okay, because I'm not prepared to necessarily explain how Webpack works right now. But this is an example that uses Webpack. We're going to have parcel one soon. So what I've done here, we've got pretty much like kind of like a very extremely basic website. If you take a look at the package.json, you can see here, I just have like a custom script that runs Webpack dev server, and I just have some Webpack stuff going on here. And here you can see that this is, I last did this at JSConf.eu. But let's go in and use our new one. Oh, I forget which version. Oh, well, I hope it's this. Probably the default one. I can actually look here. Perfect. All right, so I'm going to run npm install because we need to install our new package. But yeah, so what we're doing here is we're just installing the package that we've literally just made. It is, yes, perfect. No vulnerabilities. All right, and so if we take a look at our index.html, here we just have a simple page, and it's going to import an index.js that Webpack is basically going to make a bundle out of. We can take a look at our Webpack config. Right. Yep. So it's just putting all that in. And what we should be able to do now is run npm run serve. And, oh. Oh. Never hard code into your node modules directory. That's a mess. But I'm still going to do it for a second, just to fix this. I forgot to change this name. Should be correct. Let's try it again. What did I call it? Oh, I know what I did. There we go. Naming things is hard. All right, so now that we've packaged this all up, ostensibly this should say hello to us. Yay! So, as I said before, doing this alert is kind of like not that cool. The thing that I would like to encourage people to do, one, obviously read this if you're interested in WASM BindGen. The coolest tutorial that we have is, how many people here have ever made a game of life? So writing a game of life in Rust and then being able to display it in the browser is the kind of canonical tutorial we've been working on right now, because it's process intensive, kind of, and still a little bit fun. So this is a great tutorial to get started. Finally, the Rust and WebAssembly team has this website. This is a blog post. If you want to read more about the vision for WASM BindGen, I would strongly recommend this. Every week we do a This Week in Rust and WebAssembly, where we talk about issues that are great to get people involved. Additionally, all of our meetings are completely open, and we also record them, and they're on the Rust YouTube channel, so you can check those out. This is the team repo, and so if you follow this, you can kind of get a good idea of what's going on. We kind of have this vision statement that I've pretty much given to you already. But lastly, one of the things that has inspired me most about the Rust and WebAssembly community is that I have gotten so many people to make their very first ever Rust contribution by working on these tools. So particularly web developers, if this is something that you're interested in, we regularly mark things as good first issues and do tons of mentoring to help anybody out. Even if you feel like you don't know enough Rust to get involved, I swear to you, there was like 5 folks from JSConf.eu who came in, used the tool, like used WASM pack, and were like, oh, like you could improve the UX here, here, and here. And I was like, great, let's work together to do it. And so there's a whole bunch of awesome features in there, like built by people who literally had never heard of Rust like a month ago. So I really want to encourage you to get involved in that. And so you can check out these issues and talk to me about it. But yeah, I hope, how many people here would at least consider trying to write some Rust generated to WebAssembly today after seeing some of this? Has this convinced anyone that this is maybe a good idea? Okay, cool. I'm really excited to see what you build, and thank you so much for having me.